In the second part of the videos about implementing DHCP in Windows Server 2016, we are going to take a look into the high availability options for DHCP. Hello friends, this is Nick from NOB Solutions, and today I'm going to continue with the second part of the three-part videos about DHCP and implementing DHCP in Windows Server 2016. So in the first part we discussed how you can install the role, how you can configure pretty much your DHCP server so it can start giving IP addresses to your clients. But the next one, and this is a quite important thing, is to consider how your DHCP server can be highly available, because this role is required and it's pretty much critical for all the clients within your network without any static assigned IP addresses. And if this role is not available on your network, it will make a disruption, and the clients will not able to work properly, not able to communicate between each other. So we definitely need to think of a way to to save this one, so everyone can work without any disruptions. So for the purpose of this video, I would need two servers and one client desktop machine. The first server is my domain controller, this is 01. The second server I'm going to use is my storage server, but in this server I'm going to install the DHCP role so we can configure the settings for DHCP failover, and I can show you how things are working. But in your case, you can decide to install the role on another domain controller if you wish, or another separate server, depending on what is your environment and how you want to protect your DHCP server. And in the end, I'm going to use my PC01 so we can test the DHCP failover and confirm that it's fully functional and able to still provide IP addresses if one of the servers is down. So to start with DHCP high availability, we need to take a look into some older methods that are still present in Windows Server 2016, and you can configure them as well. And the first method of making your DHCP highly available is DHCP clustering. So the DHCP clustering, and you know that failover clustering is not a new technology in Windows Server, and what it does basically is you have two servers that share same storage, and if something happens to one of the servers, the failover cluster will detect this and will fail over all the settings to the second one, or depending on how many servers you want in this failover role, and the DHCP server will continue to operate in a different node. So this is not a new scenario. This is has been going through the years, and the DHCP failover, on the other hand, is a thing that does not require failover clustering to be implemented. So this is a question that you can see in some exams. What is the difference between DHCP clustering or DHCP failover? And you need to know that DHCP failover is a newer technology that was introduced in Windows Server 2012. And in there you don't need the failover clustering role feature to configure the DHCP failover. Split scopes, on the other hand, is another scenario which involves two DHCP servers, and in this case the two DHCP servers will split the IP addresses between each other for the same scope. So if I can show you just real fast, if I open the DHCP console and just expand it a bit. So, for example, this is going to be my server 01 that is going to give addresses for my scope. And what I want to do is this server, I can configure this to give the addresses from 100 to 200 in this example. And my second DHCP server can start giving addresses from 201 to, for example, 250. So the servers can work in the same subnet, and they can give addresses, and if the IP addresses from the scopes are not overlapping, everything should be fine. And what you can do to lower the amount of collisions that are going through when a DHCP request is going on is you can configure, for example, the delay configuration in the advanced tab of the properties, for example on my second server, and add some delay. So if a client tries to get an IP address on the network, this server, for example the DC01, will respond immediately because there is no delay. But if this is not reachable, my second server will respond after let's say 10 milliseconds delay. So this is another way for you to make your DHCP server highly available. After giving you some information about the older methods of how you can make your DHCP highly available, we are going to take a dive into the DHCP failover, and this is the latest feature that was introduced in 2012. And to be honest, I don't see any difference from 2012. I already made a video, but as this is part of the video series of how we can configure the networking in 2016, I think it's necessary for us to repeat this one. So what is DHCP failover? It basically allows us for two servers to communicate between each other, and so that they can know when the servers are fully functional, and if something happens to one of the servers, the other one will take its role to start assigning IP addresses. And of course there are multiple modes for DHCP failover, which we are going to discuss in here. So for the first thing, I want to I've already pre-installed the DHCP role into my storage server, so I'm just going to complete the configuration with the known wizard. So if you want to know how to install the DHCP role, you can check my first video. In there I've discussed and showed how to install and configure the DHCP. Now that we have the DHCP role installed on my and configured and authorized on my storage 01, I need to switch to my domain controller, where I have my scope, which I'm going to configure as a DHCP failover scope. And I just want to add a huge note in here. If you want to configure DHCP failover, this can be done only on two DHCP servers. So you cannot add more than two DHCP servers for DHCP failover, and you cannot add anything except from IPv4. So you cannot use DHCP failover for IPv6. At least this is the information that Microsoft are giving up today. So I have a single scope, and in this scope I have a reservation for my PC, and I have the lease, which is reserved, of course, and I'm going to use this scope to configure my failover. So in order for me to do this, I need to right click on the IPv4 and configure failover. So the first window is the introduction to DHCP failover, and in here, if you have multiple scopes, you can select all the scopes to make them highly available, or you can only choose a single scope. In my case, I have only one, so I'm going to just select all and click next. The second window is asking me to specify the partner server to use for failover, and I'm going to add this, and you can see that straight away my Active Directory is detecting that my storage server is an authorized DHCP server. So I'm going to select this option and choose the storage 01. So click OK. It's going to connect to the server and verify that it is suitable for configuring DHCP failover, and we should be okay. Yes, so on the bottom you can see that I have the option to reuse existing failover relationship configured with this server. So for example, if you configure a single scope with the second DHCP server, what you can do is, if you decide to make another scope highly available, you can go ahead and select the option to use the same settings as the first configuration, so you don't need to go through the wizard once again. I don't have this option available because this is the initial configuration, so I'm going to just leave the default. On the next window of the DHCP failover wizard, you will be presented with the main configurations of your DHCP failover. The first field is the relationship name, and the relationship name needs to be unique. So for example, if you have multiple scopes but you decide to create failover for a single scope, this name needs to be configured properly to represent this scope. So in the future, if you decide to make another release for a different scope, you need to use this naming convention and configure your next scope, and again, it needs to be unique. So in my case, what I need to do, instead of having the first FQDN, then the second FQDN of my servers, I will just add DC01 store 01 and then the scope itself. So the next time, if I have another scope, I can just configure the name of the scope or the network of the scope in the last field. So this is a good naming convention if you want to configure multiple scopes. The next field is the maximum client lead time, or MCLT. So this is pretty much related to the state switchover interval. So this state switchover interval is not enabled by default, but if you decide to enable this one, and if, let's say, we have the scenario where we have the two servers, and this 01 is my main server, and it's giving IP addresses. The state switchover interval is the communication between it monitors the communication between DC01 and storage01. So for example, if DC01 is not available, not reachable because of, let's say, network outage, storage01 will wait for 60 minutes before actually configuring DC01 as down. So if you don't have this enabled, the storage01 server will not automatically assign server down as DC01 at DC01, but will instead need a manual configuration from the administrator. And when you have this enabled, and when your server is detected as down after 60 minutes, the maximum client lead time kicks in, and then the storage server will wait for another hour before picking up the entire scope and start assigning, becomes the primary DHCP server. So these two are pretty much related to each other, and you need to be familiar with them in order for you to configure your DHCP failover properly. So the next field is the mode. And you have two options for configuring modes in DHCP failover. The first one, and the default, is the load balance mode. And what this basically means is that the two servers will work together to give IP addresses to the clients. So in this mode, you have the option to split the ratio of the servers. So the servers will give the same amount of IP addresses to clients. But what you can do is, if you know that your DC is your primary DHCP server and you want this server to host the main portion of the IP addresses, you can change this percentage, for example, to 80-20. And it will do it automatically. So 80% of the IP addresses will be given to clients from DC01, and only 20% of the addresses will be given by the storage 01 server. The next mode is pretty much a disaster recovery situation, and this is the hot standby mode. In this mode, you have a primary server that is actively assigning IP addresses for the scope or the subnet, and the second DHCP server assumes this role only if the primary server becomes unavailable. So a DHCP server can simultaneously act as primary for one scope, for example, and be a secondary for another. So if I take example of this scope, the 10.0.0.0, DC01 can be a primary server for this scope, and if I have another one, it can be a secondary for another one. So it's basically going to be a pretty much an X configuration, where you have two scopes that the two separate servers are active on, and two scopes that they are standby on. So this is a good way for you to configure a proper disaster recovery for your DHCP. So within hot standby configuration, you have the option to configure what is the role of your partner server. And the partner server in my case is storage 01, so I can configure the partner server to be active or to be on standby. And you need to configure the addresses that are reserved for the standby partner. The default is 5%. So in the scenario when my DC01 becomes unavailable and the storage server is not able to reach it, for example, DC01 is down, it will use this 5% during the maximum client lead time to still assign IP addresses to the clients. After the maximum client lead time has passed, my storage server will become the active member of the DHCP failover, and the DC01 will become the standby partner. So the storage 01 will pick up the primary function of the DHCP and will start assigning IP addresses to the clients. So there will be pretty much no downtime at all. So for my configuration, what I'm going to do is I'm going to lower the maximum client lead time to 5 minutes and to configure an automatic state switchover interval of 5 minutes. And this is not recommended situation because in production, if there is a small network outage, your DHCP failover will constantly go around. So I'm doing just to test and confirm that it's fully functional. And also I'm going to make my storage 01 my active server, and then I'm going to shut down the storage 01 and we'll wait for 10 minutes to pass so I can confirm that this 01 has become the active member and it has picked up the DHCP scope to assign IP addresses for my clients. And the last field is the enable message authentication. So I'm going to add a secret, and this secret needs to be there so that my servers can communicate between each other through a secure channel. So I've added the shared secret, and I can click, you can verify the settings in here, and I will just click finish to configure the DHCP failover. You can see that the process finished straight away, so it's not that it's not taking that much time. And now if I switch to my storage 01 server and open my DHCP, just let me expand that a bit, you will see that under IPv4 I have the scope that we've configured on DC01 and all the reservation information and the address pools and everything has been replicated successfully. So to monitor the DHCP failover, you can go ahead and check it from the properties of the scope. You will see that you have another tab in there called failover, and this is just a read mode only, where you can just verify the settings of your two servers and check the state of the current server and the partner server. And where you can change the settings for the failover are from the IPv4 properties. Go to the failover tab and you will see that you have maybe more. In my situation I have only one configuration and the state of the server is normal again. I see some information, and if I click edit I can change the settings of the state switchover, change the mode of the DHCP failover if I want to, and even I can change the shared secret that is shared between the two servers. So to test our DHCP configuration, what I'm going to do is, first I want to remove the reservation for my client computer, and you can see that I don't have any reservations at the moment. And I'm going to switch to the client computer, and let's force a renewal of the IP address, renew with ipconfig renew, and let's see if it's able to pick up an IP address from my DHCP server. And after successfully picking up the same IP address as before, I can go ahead and once again check my DHCP server, just refresh the settings, and I will see that I have an address lease for this computer. So what we're going to do next is I'm going to shut down storage 01, which is the primary DHCP server, and we'll wait for 10 minutes to see what is going to happen on my DC01 and if my client is still going to pick up a proper IP address. So let's shut down server storage 01, run as administrator, shut down ST0, and we'll switch to my DC01, where if I check the properties and the failover state, you will see that the state of this server has changed to normal, from normal to lost contact with partner, and the state of the partner server is not available. The role on this server is still standby. So if I switch to my client and try to renew the IP configuration, let's see if this will be successful. So you can see that an error occurred while renewing the IP address of this computer, and it's unable to contact the DHCP server. So if I go to, I assume that I would need to wait 5 minutes so that the state of the partner server can become down. So the maximum client lead time will kick in and this server should start giving IP addresses. So I'm going to pause here, wait for 5 minutes until the state changes to down, and we can continue from there. Waiting for some time now. If I go to the properties in failover tab, I'll see that the state of this server is showing partner down. So the automatic switchover state has successfully worked and my partner is now down. So the role of this server is still standby because it's waiting for the max client lead time to go through. But if I switch to my client machine and try to renew the IP settings configuration, let's see if this would be successful. After playing around a bit with the DHCP failover, it seems that what I had to do is I had to first release the IP configuration, which is here, ipconfig release, and then ipconfig renew. And what it did, it gave my client machine an IP address from the hot standby pool, which you can see starts from 197. So these are the 5% addresses that were reserved by my hot standby server to give while my active server is not online. And again, I had the real life scenario where even though my maximum lead time has expired, my DHCP server still was showing that it was on standby mode. So I looked around, I did some configuration and some search, and I found that this state will not change. Unfortunately, I think this is going to be fixed in the future, but this is, I think, a known problem that it's only cosmetic, just showing that the server is standby and it's not becoming the active member. But what I did is I went ahead and configured some additional network cards on my client machine. So I've added additional network cards and gave them the automatic configuration on all of them. And after switching to my DHCP server, I noticed some strange behavior. So if I open the scope and check the properties under failover, I will see that the role of this server is still standby, which is again, I said it's a strange thing. And the failover, if I go to the settings, I will see that the role of this server is again standby and not deactive, what I was expecting. So what happened in the real life is the server gave IP addresses, all the IP addresses that were available from this hot standby, and afterwards it gave the IP addresses from the active partnership that was configured in the failover. So even though it's saying that its hot standby mode is currently on standby, it will assign IP addresses from the active member and will give IP addresses to the client machines that are requesting. Even in the display statistics field, I found that the IP addresses available in this server pool are 0, and the addresses available on the partner pool were 95%, it gave the actual IP addresses for the network cards from the partner pool. So again, after running the full auto-state switchover interval and then the maximum lead time, indeed it took the ownership of the full scope and it started giving IP addresses for the clients. So you can see that our DHCP failover is fully functional, and we even tested the hot standby mode and found some additional things that hopefully in the future they will be fixed, so you won't expect anything, or you won't be baffled around why your standby server is not becoming the active member when the partner is down. So if you like the video, you can always subscribe to NLB Solutions. You can always hit the like button. That would be really helpful for me. You can always share the content around the web and show to your colleagues. If you don't like the video, you can always hit the dislike button. Leave a comment to tell me what can be improved, and we can improve it in the future. If you have any questions, leave them in the comment section. I will try to answer them as soon as possible. This was how you can configure DHCP failover on Windows Server 2016. This was Nick from NLB Solutions. Thank you very much for viewing, and see you in the next video.